right, I'm Bertram Al. I'm the last speaker here, so I'm going to talk a little bit about value alignment. The AI craze has turned a little bit into AI fear, and one term that people have mentioned here is that our robots in AI need to be aligned with human values. And Stuart Russell has been a strong proponent of this idea, saying that AI's utility function may not be perfectly aligned with the values of the human race. We need to build intelligence that is provably aligned with human values. And that is true in principle, but there are a number of problems. The first is, what even are human values with which an AI needs to be aligned? How would values be represented in a utility function? And the problem with some of the terms here is that values are not value. A utility function is a value function, but values are something quite different. They're not even preference orderings. In fact, when you look at the literature on values, there are things like freedom, privacy, autonomy, equality, very important, but they're abstract, they're vague concepts. They have a lot of social attachment function. We form an identity that's shared when we share values. But as computational structures, I'd say they're hopeless. So we've taken a different approach and said, well, maybe there's something that can serve the same function of aligning human interests and human importance with what we build on the AI and robot side, and look at norms. Norms are concrete. They, as you will see in a second, they are definable as instructions to act and something that we can actually build into computational systems. So norms in sociology and economics, social psychology have typically been described as forces that impinge on the individual. And in very few of these studies, people have talked about the cognitive structure of norms. So what's actually in the head that makes me sensitive to the external forces? And that has to be something slightly different from beliefs, desires, intentions, habits, personality dispositions. Because that sensitivity to external societal factors has some unique features, or so we argue. And so a working definition that we've started with, really Christina B. Carey and a group of philosophers around Brennan have proposed something that we've slightly restructured into the following definition. A norm is an instruction to perform or not perform an action A in context C, provided that two conditions are fulfilled. One, that a sufficient number of individuals in the community demand of each other to perform A. So there's an expectation, a normative element in that sense. But also that a sufficient number of individuals do in fact perform A. Because there might be an expectation, but if you realize that people are just hypocritical, they expect me to be nice, but they're not, then I'm not going to see this as a legitimate norm. So a norm has both this truly strongly community demanding element and an empirical fact, both of which need to be there for a norm to be present and for an individual to be sensitive to that norm. So that's the starting point, and we've worked with a few formal ways of implementing that. I'm going to get back to that. The D stands for deontic operator, specifically geared towards a context C, operating on an action, and that is a very simple first working definition for a norm. So the goals in our research are twofold. First, to identify the properties of human norm networks, what it actually is in our heads that makes norms work in society, and then develop a computational model of these norm networks that preserve the properties and make these robots adaptable to societal communal relations. And a few of the properties of norms that we've been studying, I'm going to list here and then give you just very brief evidence on these issues. Community presence, the very definition of norms, implies that if a norm exists, it's got to be distributed in at least a reasonable consensual way in a specific community. Not necessarily in the entire world, but in the community that might be a small community, might be a larger community. Context specificity that we've really started from the start, we're convinced, but there isn't necessarily good evidence, so we try to provide some evidence. Activation speed is a very important element. If norms are context specific, and if we are supposed to really respond to norms of interactions, of particular contexts, then they need to be activated very quickly. And I'll show you a little bit of evidence for that. Just imagine you come into a room, what you're supposed to do and not supposed to do needs to be quickly available. And it's to be very different from the norms when you go into the public bathroom. And we don't normally have to think about or look up on our cell phone. Those get activated pretty quickly. fourth, we were, again, as part of the working definition, thinking of a possible network structure. Maybe not the same as semantic networks, but maybe some cognitive features that we know from semantic networks might also apply to norms. And finally, more recently, we've found some evidence that norms are not strict, do this, do that, but rather come in degrees of that normative force. So I'm going to illustrate all these 5 points with a little bit of research, and I'm introducing 2 experimental paradigms. One we call the generation paradigm, where basically we take photos as the elicitors of specific contexts, and then ask people one of these questions. What are you allowed to do here? Or in another study, what are you permitted to do here? That would trigger a permission. What are you supposed to do here? Or what should you do here? What are you obligated to do here? That is supposed to elicit prescriptions. And what are you not allowed to do or forbidden here? That is supposed to elicit prohibitions. And then people basically get a photo, get one of these questions, and then have, in one study for 60 seconds, in another study for 30 seconds, just time to type whatever they think the answers to those questions are. Type 1, hit return. Type another, hit return. That's all. It's a fairly transparent, a fairly intuitive task, and most people come up with about 8 or 9 codable or usable responses in a minute, and about 6 in 30 seconds. After 30 seconds, people sort of grasp for additional things, and they become a little strange. First piece, community presence. What is the level of consensus? Well, what we find here is that the most frequently mentioned norms for any given context, these are now averaged across 8 scenes, are in the 80s, 81 and 77 for permissions and prescriptions. The second most frequent one, 68, 57, and then it declines. The 7th most frequently mentioned one is only mentioned by about 23, 28% of people. So there's consensus for the most frequent ones. This is not just a mathematical triviality. They could all be pretty low and widely distributed around a large number. There is clearly a subset that almost everybody mentions. But notice that prohibitions also have this decline, but start at about 49% on average, which struck us as very interesting. Why do people not agree on prohibitions, what you're not supposed to do, what you're forbidden to do, for the same very context that we asked about permissions and prescriptions? Wonderful first puzzle. Second, context specificity. What we did here is we listed all the actions that people typed out and traced them to which context they were typed. And then just checked whether any given typed action showed up only in one context or in other contexts. So you have a matrix where basically this is almost an identity matrix in the sense that for any action, we find exactly where it was mentioned, except it wasn't mentioned in almost any other context. This is radical locality, what I would call it. And in terms of numbers, 3 out of 56 norms reappear in a second scene. 3 out of 56. So 95% of generated norms are context unique. Another bit of context specificity, now still pretty impressive, but again, different for prohibitions. We find now more deviations from the identity matrix. That is, there are more actions that are forbidden not just in one context, but in multiple contexts. Still, we have 75% uniqueness, which is still quite remarkable. And of course, people didn't know about any of the other contexts. It's not like they selected the one that would fit. They selected the one that came up for them, and then many other people came up with different ones for different contexts. And we'll get back to context specificity in a second. Second paradigm is a detection paradigm. So we take the norms that people generated for these very scenes and feed them back to people. So rather than you having to generate the norms from sort of your memory, type them out, I give you various of these norm-guided actions, and I simply ask you to tell me whether the norm applies to the scene or not. Very quick yes-no responses to the questions, are you allowed to do this here? Are you permitted to do this here? Are you supposed to do this here? Should you do this here? And finally, are you not allowed to do this here? Are you forbidden? So you get these actions, you get the picture, you get the question, and it's the same question, and you just get 1, 2, 3, 4, 5, 14 of those brief action descriptions, and you just say yes, no, yes, no. Fairly simple task. People actually enjoy it because it's over soon. So you get something like swimming, and you say, no, it's not forbidden. Yelling, yes, it is forbidden. And it depends, of course, on the context. You get one context, you do this, you get another context. In total 4 contexts that any given individual worked on. But we did a little trick here. For every scene, we selected 14 norm-guided actions, half of which were the top 7 generated for that scene. So they were the local top norms, plus 7 foils, if you will, that came from the top 7 sets of the other contexts. So you have signal, if you will, and you have noise. And the question is, do people distinguish between them? Context specificity would predict, yes, absolutely. They can tell whether this norm applies to this context or doesn't apply. Secondly, if activation is fast, then you should be very quick in recognizing the local norms and slower to recognize norms that might be applicable but actually don't come typically from that context. So 2 things, rate of yes responses and reaction time, were these variables that we could measure, again, from our participants. And we, in these studies, all use Amazon Turk participants. They come from a relatively broad range of educational, political, religious, and age background. Not a perfect representative sample, but people have actually shown that Amazon Turk samples are very similar to representative, very, very expensive national samples that people have worked on in the past. All right, quickly, context-specific activation. So this is sort of part 2. What you see here is for each of the scenes, library, beach, boardroom, cave, the rate of yes responses for the local norms in darker blue and the non-local norms in this more grayish color. There are, of course, several non-local norms that people, when considering, said yes to. But there's a clear difference, 96 to 66, 92 to 56, and down here. These are the first 4, the next 4. Same thing, 94 to 70, 96 to 62. In terms of signal detection theory, we can assign an actual number to this. And the number, the D parameter, that is the discrimination between the local and non-local norms, is 1.16, and across these 8 scenes varies from 75 to 1.49. And the beta parameter is sort of the response bias. People were willing to say yes to a lot of those norms. So when offered the possibility to say, does this apply? People said more often yes than our generation data would have suggested. But there is pretty strong evidence for context specificity, even under these circumstances. But again, there's variation by norm type. Here you see on the left and in the middle permissions with 2 different probes, and they show exactly the same result, allowed and permitted, and supposed and should, which are the prescriptions. We show in the 90s down to the 50s, but for prohibitions, you barely get a separation. People do recognize the local norms that people have previously generated, and they give them about 77, 82 yes responses. But they also say almost to the same degree yes to ones from other contexts. So much less context specification, if you will, or specificity for prohibitions. And we see the same for the other 4 scenes. And these are between subjects. So these are almost like replication studies, if you will, across different stimuli, stimulus representativeness. All right, and in terms of signal detection theory, you get 1.51, 1.58 for prescriptions and permissions, and 0.47, still significant, but much, much less for prohibitions. Activation speed, so that's the reaction time of these yes responses. And again, reminder, if there is some kind of network, something that's quickly activated, specific to this context, then you see the picture, it gets activated, and whenever I ask probe one of those, you should very quickly say yes. When, however, there is something from a different context that still warrants a yes response, you may have to retrieve that specific norm, check whether it works, and then say yes, should take longer. So you can contrast activation or pre-activated, primed, versus retrieved. What we find is, first for prescriptions in the middle in blue and permissions in green on the left, for these 2 probes, very similar. These are the yes reaction times to the local norms. 1100 milliseconds. This is how long it takes you to decide whether a word that I'm showing you was just occurring in a sentence that I showed you before. This is very, very fast. This is how long it takes people to determine, and they agree on these things, whether a norm applies to a particular context or not. 1100 milliseconds. Prohibition, 14 to 1500 milliseconds. This is pretty extreme effect size. And replicated, now the not allowed probe still takes a little longer because of that negation word, but even the forbidden word takes 1400 milliseconds. So these are the yes reaction times to the local norms. What about the non-local norms? We see that for permissions on the left and prescriptions in the middle, they are still pretty fast, but they're clearly slower because it appears, at least by our interpretation, they have to retrieve whether that norm applies rather than have it pre-activated. But there's no advantage for the local versus non-local norms for prohibitions. It's as if people have to retrieve in each case. Does this prohibition apply to this context? Yes, no. And it didn't matter whether I offered people a local norm that was previously generated by another independent sample of people as, yes, that's what you're not supposed to do here, or whether it was a non-local norm from some other scene. So this was quite remarkable. We had in our research team like bets going whether prohibitions would show stronger effects because they are negative, because there is a lot riding on them, they're risky, or whether it's actually harder to come up with prohibitions because typically when we guide our actions, we guide it in the terms of what am I supposed to do, what should I do, rather than what is it that I'm not supposed to do. There's an almost infinite number of things I'm not supposed to do. So when you come into the room, you're probably not going through this infinite list. The 2-3 things: get your chair, don't annoy the speaker, maybe pull up a water bottle, sit down, quiet. 3 things. There are tons of things. You shouldn't stab somebody with your pencil right in the eye, and many other things that you wouldn't even have thought of right now, until I told you this ugly picture. Anyway, so for prescriptions and permissions, it looks like local endorsements are faster because they are pre-activated just by looking at the scene, relative to non-local ones which are retrieved. And for prohibitions, it seems that both local and non-local endorsements are slower because in both cases they are retrieved, and even retrieved more slowly than in the case of prescriptions and permissions. Network structure, I'm going to show you just a cool picture because we haven't yet done a lot of work on that. We have a lot of data and they are being analyzed. We throw all the actions together into one big, if you will, huge correlation table and look at co-occurrences of these actions. And what you find is the network that's formed finds the pockets of context. So there is, in fact, this, what you would expect from context specificity, this clustering of actions that are similar and form like a little island over here, another island here, another one here. So I color-coded basically the ones that actually came from a scene. But of course, the network analysis tool didn't know where they came from. So you can recover these context-specific patterns. This is for prescriptions and actually looks more compact for prohibitions. But if you have a much better data set, many more numbers, and are going to redo all these analyses with more sophisticated networks, network tools. But what's also interesting that suggests this network idea is that those that were most frequently mentioned were also the ones that were mentioned earlier. And this is not, again, a mathematical triviality. You could have in any, let's say the first 5, the first 7, you could have the moderately frequent ones first, then the highly frequent one. People don't know what others are doing. But it turns out that it appears that the first thing that comes to mind is the one that's typically also mentioned by other people, and typically also very early on. Now, 0.33 to 0.38 correlation may not be massive, but the kind of error variance that you have across so many different norms is quite remarkable. So this is also interesting in the sense that the norm network might have a core and then a periphery, and you start at the core. But is the network really in the head, or is it in the world? This is just a teaser. We've really started recently to think about, this is not really visible, so let me tell you in 2 sentences. It could be that we have this network, like a semantic network, and stimuli in the world activates that network. And so when you come into a room, bingo, the network's there and you can act on it. Or it could be that you farm it out to the world. You basically don't carry around norm networks. You let the correlation of objects and cultural symbols in the context do the job of individually triggering norms. So down here, it's basically features of contexts individually trigger norms. This microphone tells me what I'm supposed to do or not supposed to do with respect to the microphone. A chair tells me that I should sit down. And many other objects carry the cultural traces of what you're supposed to do and not supposed to do, a form of normative affordance. And I don't have to remember all that. I'll just let the world, in a sense, tell it to me. And if the world has correlated objects, you get correlations among the activated norms. This seems crazy, but I'm fascinated by the idea that the human mind, because it has developed these massive norm networks in the last 10,000 years, when we have settled and lived with tons of strangers, we didn't evolve any new mental machinery. So maybe we just let culture leave its traces and activate these things for us. So this is a new possibility, and we've started to look at actual objects and contexts. This is from the Sun database, and look at whether certain objects are actually characteristically defining certain contexts. And if so, then we could present these objects to people and see whether they activate people's norms. All right, the final thing, and this is just going to be brief, the intuition in deontic logic and in many other formal systems was that they're clearly categorically different norms. There are prescriptions, permissions, prohibitions. And this is what I've been talking about. But really, if you stand up in church, pull up your boombox, and blast this kind of music you like, that's a much stronger norm violation than if you don't stand up when all the other ones stand up. It's also a norm violation. They might look at you funny, but it's much less bad. So there are differences in how much normative force there is for certain norms. It also, of course, leads to more sanctions if you violate a stronger norm. It's all intuitive, but somehow hasn't really reached the formal modeling in computational systems and in deontic logic. So the question is, can we show that people actually have a sense of the gradedness of norms? And rather than having three categories, you basically have maybe a continuum from absolutely, yes, you really should, to, no, you could if you wanted to, no, absolutely not. Maybe it's just one dimension. So we used a couple of different methods. A ranking method first. We gave people a bunch of descriptions: advised, advocated, appropriate, binding, discretionary, essential, expected. What our language has to maybe differentiate degrees of norms, in this case prescriptions. And ask people to simply sort them from top to bottom. Just most prescribed to least prescribed. We weren't even sure that people could do this, and they show actually remarkable consistency in this. We did the same for prohibitions, and built into each list were also a few permissions, where we thought this is kind of harder because it's sort of the absence of either one. What do we find? We found a remarkable separation. These are not all, these are the best separating one. On the x-axis, you see the ranks, the average ranks for these words, and we can basically, whoa, well, we cannot see. You see here expected, essential, required, mandatory. They're basic, these are 95% confidence intervals. They're basically non-overlapping words that describe different degrees of strength for prescriptions, and up here, different strengths of prohibition. And then you have sort of the crowdedness down here of permissions, or mild prohibitions. I think I'm running out of time, so I'm going to jump through this and show you just the very last. Let's actually go to this. The very last slide, a reminder that these properties of norms are really a starting point to study something that, for some strange reason, psychology hasn't looked at. And the only reason why we started to look at this is because my colleague and I said, we need to build norms into robots if we want robots to be members of communities. So how do we do this? And there was nothing in the psychological literature that could give us guidance. So we started this research program really with that same idea. We need to understand humans, like Justine Cassel said earlier in the keynote talk. Understand humans first and then give us guidance. Robots don't have to look exactly the same, but they need to match somehow those properties, and maybe alignment is in part the operation of how the system works, and the specific norms between a robot and a human might be very context-specific, might be relationship-specific, culture-specific, but we might then know how to actually implement that. Thanks for your attention.